and go. Okay, today we are going to cover system of equations. We covered it before with SAT4 as well, so it will be a quick review. Okay, you can use mouse here, much faster. System of equations. Can you find a blank area or white area? Let's see. Okay. So it's here, system of equations. Yeah. Let's start. System of equations, the name of the topic. Oh, draw something. System of equations. In this topic, we are going to cover the relation between two lines. Okay, so in SAT we don't have second order system of equations. We only have first order system of equations. That means the power of x or the power of variable x and y, both of them are 1. So we don't have x to the power of 2 equals to y or something. So it will be second order, or maybe if the power of x is 3, it will be third order. We don't have that. We have only first order system of equations. Let's say we have 2x. You know that if the power of x is 1, if the power of x is 1 and y is alone in one side of the equation, we can present a line using this. How? Let's draw a line using this equation. So here we have 5 as constant when y is alone in one side of the equation, and in the other side of the equation, if the constant, if we have the constant that is my y-axis, the line intersects the y-axis in that point, which is 5. Okay, so this is y-axis, this is x-axis. So here is 5, let's say. Okay, and my line will intersect the y-axis in this point. And to find the intersection of the line with x-axis, I will put y0. So it will be 2x plus 5 equals to 0. And I will find x as minus 5 over 2, which is minus 2.5, which is here. Okay, let's say it's here, minus 2.5. So my line intersects these 2 points, so I can draw a line like this. So this is my 2x plus 5 is equals to y line. Okay, so it's super easy. You just find the y intersection, x intersection with x-axis, and then you will draw a line using 2 points. Okay, I can erase this. In system of equations, do we have people coming? I think people, I mean, students can enter by themselves, right? I don't have to approve their request to join because I disabled waiting room. Yes, okay. They can't? No, they can because I disabled the waiting room option, so they can enter. So I can close it. Okay, so in system of equations, we have 2 lines, and we will find their relation if they are intersecting in one point, if they are never intersecting. If they are never intersecting each other, that means these are parallel. Okay, there's only one condition. If they're not intersecting each other, that means they are parallel. So if I have a line like this and like this, maybe, as you can see, these are not parallel. If it goes to infinity, as you know, lines goes to infinity, in some point they intersect, okay? So if my lines are parallel, that means they are not intersecting each other. And if they are not parallel, that means they will intersect in some point. Okay. So in system of equations, we have two lines. Let's say 2x plus 2y is equal to 5. And 5, let's say 5y minus 3x equals to 2 maybe. Okay, so in here we don't have y alone in one side of equations. If you want, you can find this equation and do some calculation and find something like this. Y is equals to maybe 5 minus 2x divided by 2. You can do some operations and find the equation as this form. But before that, before doing this, we have some ways to find the relation between them. Okay, so my equation should be in this form. I mean, x's and y's should be in one side of the equation, and the constant should be in other side of the equation. So we will take the ratio of the coefficients. Okay, the ratio of the coefficients, the ratio of coefficients of x, which is 2, and here we have minus 3. And let's take the ratio of the coefficients of y, so it'll be 2 divided by 5. Okay, so if these are not equal to each other, these lines have one point of equation, one point of intersection, one point of intersection. And if we have something like this, for example, 4x minus 10 is 10y, let's say, is equals to 3, 8x minus 20y is equals to 6. Let's take the ratio of the coefficients, 4 divided by 8 and minus 10 divided by minus 20, and if I see the equation here, I mean, if I divide this by 4, 1 divided by 4, so it'll be 1 over 2, sorry, 1 over 2 equals to, if I cancel this, to be 1 over 2 as well. So the ratio of the coefficients are equal. I mean, the ratio of the coefficients of x and y's are equal. And in this situation, I will look at the ratio of the constant, which is in the other side, which is 3 and 6. Is it equal to this as well? Let's see. 3 divided by 6. Is it 1 over 2? Yeah, that's it. That is 1 over 2. That means the ratio of the coefficients of x and the ratio of the coefficients of y, and also the ratio of the constants, all of them are equal. That means these are one line. By that I mean this is a line and this is also a line, but these are on another. Okay, let's say this is line 1 and this is line 2. If let's see, if this is line 1, let's say, so this should be line 2. Okay, so these are one line. If you divide by 2, you will get the same equation. So that means these two equations have infinite number of intersection. By that I mean infinite number of solution. For this, it has one point of intersection. That means one solution. And let's go down. Oh, I cannot do that. So let's clean this. So if we have uh, all the ratios equal to each other, that means those two lines are one line actually, and those have infinite number of solutions. But what if we have something like this, for example, minus 2x plus 4y is equals to 5, and 4x minus 8y is equals to 8. Let's take the ratios of the coefficients. Minus 2, the coefficient of x is minus 2 here, and the coefficient of x is 4 here. Don't confuse the coefficients. Sometimes x could be here, like here. You should not take 2 divided by 5. No, you should take the ratio of the coefficients. That means you should take 2 divided by minus 3. So here we do the same thing, and I'm looking for the relation between the ratio of the coefficients of x and the ratio of the coefficients of y. So it will be 4 divided by minus 8. If I cancel this, it will be minus 1 over 2. And if I cancel this, it will be minus 1 over 2 as well. So these are equal. And if these are equal in this situation, I will look for the ratio of the constants, which is in the other side of the equation. I will take 5 divided by 8. If I take the ratio of these two numbers, are they equal to minus 1 over 2? No, it's not equal to minus 1 over 2. In that case, in this case, these lines, and these lines, these two lines, line number 1, let's say that number 2, these are parallel. Okay, these are parallel. That means they never intersect. If they are never intersecting each other, that means these two lines don't have any solution. Okay, is there any question until now? Is there anything unclear for you? If you have any question, you can write it now. I'm waiting. Okay. No question? I will move on then. Who are those 18 students? Yes, Musawir. When it's parallel, there's no solution. Yeah, there's no solution. Intersection means solutions, okay? Just memorize it. If there's no intersection, that means there is no solution. Okay. So let's clean this, clean all my drawings. And so we know how to find the relation between two lines. I mean, if you have one first order equation, that's a line. That's how you do it, how you find the relation. No problem. So let's solve some questions here. And there's also another way to find the relation. I mean, you make it equal to each other, then you find a value of x, or you have different values. In that situation, let's solve an example about that. That way it could be a bit maybe easier. Let's say if you have 2x plus 4y, if you forget about the relation between them, which one was equals to which one, so that we have parallel lines and we have intersecting line, or we have the same line. You can use this method, for example. if you have something like this is equals to maybe 2x minus y is equals to let's say 5. Okay, you use elimination method. You will eliminate one of these terms, x or y, doesn't matter, and then you will find a number. I will show you what those numbers means. I mean, if you have a solution for that, so it could be different according to their relation. I mean, these two lines. So let's cancel y's. Here I have 4y. Here I have minus y. I need to have minus 4y in order to cancel 4y. So I will multiply with 4. 4, 4. So it will be 20, right? 4 times 5, it will be 20. So 4x, I will sum them now. 4x, 2x will be 6x. These are cancelled, and I have 22 here. So x will be what? X will be 11 over 3. So here I found a value of x. In this case, if I have found a value for x, in this case we have one intersection. Okay, in these two lines have one intersection. So if I had found something like this, 11 is equals to 6 is equals to 11. In this case, I don't have x. I have inequality. Okay, there is an inequality, but in this case, since the equality is wrong, we don't have such equality. 6 is not equal to 11. In this case, there is no solution. But what if I had found something like this? 2 is equals to 2, which is always true. I mean, logically 2 is equals to 2, right? So in this case, there are infinite solution. In this case, we have one solution. If I have an inequality at the end of this elimination, when I do the elimination, then I will find something like this. If I have something like this, for example, this is inequality, there's no solution. Basically, you can see there's no logic way to think that 6 is equals to 11. That's why there's no solution. And when you find something like this, 2 is equals to 2, that means there's infinite number of solution. What does infinite number of solution means? That means you can put any number, I mean infinite number of x's and y's, then it will be equals to 2. So you can put infinite number of numbers in order to hold this equation. What about this one? This means that there is no such value that if I put it in x and y, so that will be equals to 2. There's no such value. Okay, there's no solution. And what does this mean? This means that I have one number of x and one number of y, such that if I put it here, it will be equals to 2. Okay. And also it should be the equation should be whole for this one as well, for both of them. Okay. I mean, when you find x as this number, you put it here and you put it here, you will have one value of y such that if I put it there, it will give me the equality will hold. Sorry. My bad. Sorry. What do you mean infinite number of solutions? Did you get your answer, Dennis? Okay. Dennis, did you get your answer? So these graphs are not really okay. Infinite number of solutions. I'm going to explain it again. Infinite number of solutions. Let me explain. infinite number of solutions means that we have 2x, let's say minus 5y is equals to 5, and 4x minus 10y is equals to 10, minus 10, or plus 10. And these two equations have infinite number of solutions. Infinite number of solutions means that there's infinite number of x's and y's, such that if I put it here and here and here and here, it will hold this equation. So this one is representing a line, and this one is representing another line, and these two lines are the same line. Okay, these two lines are the same line. Infinite number of solutions, infinite number of intersection, because that line is on another line, and it has infinite number of solutions, and we can say it has infinite number of intersections. That is the
Can I
meaning.
ask a question?
You
I just joined, and why do we have a lesson today?
are you
Isn't
following
today?
the group?
Yeah, I was following. However, I didn't. I thought it was wrong because
It was wrong.
it's the weekend, and we normally don't have a lesson on the weekend. So
No, we didn't have any lecture previous week, right? I
oh
had to do
yeah.
something, so I couldn't do the lecture. That's what we are doing
Mm-hmm.
now.
Ah, okay, okay. So okay, that's okay. All right, okay.
Let's continue then. Okay. Let's solve some examples. I mean, these explanations are quite similar to mine. Okay, so you don't have to know all this. You only know you only have to know my ways. That will be enough. These explanations are for those who are new to math, or for those who are not familiar with mathematics. How about this one? You should be able to solve this now. We have two equations, we have two graphs. It says a system of two equations and their graphs in xy plane are shown above. How many solutions does this system have? Solutions means intersections. We have two
Two.
graphs. Yeah, we have two graphs, right? One is which is representing this one, and the other which is representing this parabola. So these two graphs are intersecting in 2 points. That means that we have two values such that if I put it in this equation, okay, we will end the lecture in about 10 minutes. Okay. Where was I? Okay, here. Uh, there's two values such that if I put it in first equation, in this equation, it will give me a value of y, and if I put it here, it will give me another value of y, which is quite similar to each other. Let's prove it. Okay, so I will make it equal to each other. First I have to find y's in both of the equations. Y squared is equals to x plus 3, and here I have y is equals to absolute value of x, and here so I have what, if I take the square root of this one and this one, wait, sorry, so it will give me y is equals to square root of x plus 3. So I have y here, I have y here. I can make it equal to each other. Why I make it equal to each other? In order to find the intersection, because in this points, y's, I mean this y number 1, and for line it will be y number 2, let's say. These two y's are equal. That's why I'm making it equal to each other in order to find those x's. I mean this one's. X plus 3 is equals to absolute value of x. When I do this, I will find two values of x. Okay, I can find 0. No, can I put 0? If I put 1 or -2, or So there are some values. It could be fraction. Okay, sometimes it would not give me a whole number. Maybe it's fractions, but there will be two x's such that if I put it here and if I put it here, it will give me the same values of y's. Okay, so there is two solutions. There is two values of x's such that if I put it in these two equations, it will give me the same y's. Okay, so we will solve one, no, maybe two more questions, then we will stop here and give a break. Okay, this one, question number 1. So, what is the solution xy to this system of equations? In order to find the solution, we use elimination method. So, in order to solve it faster, we transformed this into our normal form, which was x was in x and y's were in one side of equation, and the constants were in other side of equation. So 3x minus 5y is equals to minus what, 11, and if I take this here, so it'll be 3y plus x equals to 1. I use elimination method. That's why I have to cancel one of these terms, x or y, doesn't matter. I have 3x here, I have plus 1x here. If I multiply it with a negative 3, so I will get minus 3x. That way I can cancel plus 3x with negative 3x. So it will be 3x minus 5y is equals to 11. So the first one, I didn't change it, I didn't multiply it with anything. But the second one, I multiply with negative 3. So it will be negative 9y, negative 3x. And don't forget to multiply this with this one, because in order to have equality, in order to hold the equation, I need to multiply each term with negative 3. So it will be negative 3. So I can cancel, if I sum them, I can cancel them. And if I sum y, so it will be minus 14y equals to minus 14. I can cancel negative with negative, 14 by 14, so y will be 1. So that means y is 1. In order to find x, you found that y is equals to 1. You found one value for y. If you found something like this, 6 is equals to 5, that means there's no solution. If you found something like this, if you had found something like this, 6 is equals to 6, that means it has infinite number of solutions. So what we found was y is equals to 1. That means we have one solution for the system of equation. So we put it here in order to find x. So it will be 3x minus 5 is equals to minus 11. So 3x will be equals to what? Minus 6. And x will be minus 2. So that means these two lines are intersecting in one point, because we found y is equals to 1. That means one intersection. That intersection happens in this point, minus 2 and 1. Okay, welcome back. We will continue with solving some questions, and then we will discuss about some spatial graphs, the movements of the graphs. How do we move a graph 2 steps up or 2 steps down, or to left or to right, and then we will discuss about how to identify a graph with its equation, and then we will finish our lecture. Okay, so question number 1 is solved. Number 2, number 3, number 4 is identical. You can solve it by yourself. Let's solve question number 5. It looks a bit maybe identical to others, but let's solve it anyway. Question number 5. So we have to transform this equation into our original form. Then we will be able to solve it really quick. So let's move x's to this side, so it'll be 5x plus y is equals to 8, and then you have minus 3x plus 2y is equals to minus 10. Here you have 2y, here you have y. If you multiply with negative 2, you can cancel them. So I will multiply this first equation by negative 2. So it will be minus 10 minus, let me write it here, minus 10x minus 2y is equals to minus 16. I multiply this equation by minus 2 to get this one, to cancel y. So we cancel one of the terms, then we will find a value of x. We can cancel y's, so it will be minus 13x is equals to minus 26. I can cancel the negatives, so it will be 13x is equals to 26, and x will be equals to 2. We found a value for one of the variables. That means we have only one intersection, one solution. We found x. In order to find y, we put it in one of the equations. This or this doesn't matter, it will give you the same answer. And when you do that, so it'll be minus 6x minus 3 times 2 will be minus 6 plus 2y is equals to minus 10. Move minus 6 to other side, so it'll be 2y is equals to minus 4, and y is equals to minus 2. So these two lines are intersecting on which point? The point is 2 minus 2. These two lines are intersecting in this point, only this point. Okay, so it's asking for x multiplied with y. You multiply them, so to get x times y, you multiply 2 with negative 2, it will be minus 4. So the answer is minus 4. And let's solve question number 6. Read all this. We have one chat. Yes, I see now. Let's solve question number 6. Okay, I'm slowing down. By the way, this lecture is recording. I'm recording this lecture. You can watch it later with the feature of YouTube, which you can slow it down. Okay. So, question number 6. We transform this into our original form, and then we will solve it. The equation. Let's read the equation. The equations of two lines in the xy plane are shown above, where a and b are constants. These are not variables; these are constants. We have to find them. If the two lines intersect at this point, what is the value of a? So we know the intersection point. We place it here, then we'll find a and b. So to place it here, because we don't have a here, we have only minus b. Place minus 2 and 8 in this equation in order to get b. So y is 8, right? When y is 8, x should be 2, right? So b times 2. I place this point into this because this is valid for this line. This point is on this line, that's why I can put it. So b will be minus 4. I found the value of b. Now I place this point in this equation in order to get a. So to be 8 is equals to 2 times a. b was minus 4, so minus 4. Take minus 4 to the other side, so it will be 2a equals to 12, and a will be equals to 6. Okay. About this one, so it should be quick, because it's asking for the how many solution does this system of equation have. If there is no intersection, there is no solution for this system of equation. As you can see, this line goes to infinity like this, and this parabola is going to infinity like this. Are these intersecting to each other? No. There is no intersection, there is no solution. 0. Okay. And these are identical to others. Maybe let's solve question number 11. Let's read it. in the system of equations above, a is a constant. If the system has one solution, which of the following cannot be the value of a? So if there is no solution, that means the ratio of the coefficients of x should be equals to the ratio of the coefficients of y, and these two should not be equals to the ratio of the constants. Okay, so let's take the ratio of the coefficients of x, which is a divided by 3. It should be equal to 2 divided by minus 6. It should be equal, and this should not be equals to 5 divided by 20. This is the property of system of equation which has no solution, which has, sorry, one solution. I made a mistake. Sorry. It has one solution. That means these two coefficients, I mean the coefficients of x's and the coefficients of y's should not be equal to each other. That is the criteria of system of equations which has one solution. I made a mistake. Sorry. So it should not be equal to 2 divided by minus 6. Okay. So if I simplify this, it will be 1 divided by 3. It's negative. So a divided by 3 should not be equals to minus 1 over 3. So which one of the following, if I put it there, cannot be the value of a? If I put minus 1 here, so it will be minus 1 over 3 cannot be equals to minus 1 over 3. So I cannot put it there because I have to have an inequality here. I don't have to have equality, because if I have equality sign here, I would have a parallel line, not intersecting line like this. If these are intersecting in one point, the coefficients should not be equal to each other, the ratio of the coefficients. You take the ratio of the coefficients of x and y's, and these two coefficients or these two ratios should not be equal to each other. That way we will have two lines which are intersecting in one point. Okay, the answer is A. We have a chat here. Let's see, who is this? Can we solve question number 8? We can solve, yes. Of course. With pleasure. Okay, let's transform this into our original form, which was minus 5x. All x's were, and all x's with all y's were in one side of the equation. That was my original form. So I will transform this into my original form. So it will be, if I move y to the other side, it will be minus y equals to 2. And if I move all this here, and if I multiply this, I should simplify this and turn it into our original form. So it'll be 4x minus 2 equals to 3 minus y, right? 3y. And I will move constants to the other side, this side, and y's to this side. So it'll be 4x minus 3y is equals to 5. I have this here. I have minus 5x minus y is equals to 2 here. So I need to cancel one of the variables. How can I do this? I have 3y here and I have minus y here. I need to have plus 3y, right? So in order to have plus 3y here, I multiply with negative 3. When I multiply this, it will be plus 3y, so I can cancel it really quick. So if I multiply it, so it'll be minus plus 15x, because minus will be positive or plus. And when I multiply minus 3 with minus y, it will be plus 3y. When I multiply minus 3 with 2, it will be negative 6. And here I have this one. I can sum them. When I sum them, y's will be cancelled. So when I sum this with this, I will get what? Y's will be cancelled. I can cancel y's. Plus 3y minus 3y cancels each other. Plus 4x plus 15x will be 19x. And when I add 5 with minus 6, it will be minus 1. So x will be Did I make a mistake? Plus 3y. Where did I make a mistake? Ah, okay. So when I move it up here, it'll be plus 4, 3y. I made a mistake here. Yes, I made a mistake. Sorry. It's Ramadan, you know. It can happen. So let's solve it from over. And this time I will be quick. Minus 5x minus y is equals to 2. And then I have 4x minus 2 equals 3 minus 3y. And then when I move all the variables to one side, so it will be 4x plus 3y equals to 5. And in here I have 5x minus y is equals to 2. So now here I can cancel this. When I multiply with 3, I have to have minus 3y in order to cancel with 3y. So it'll be minus 15x minus 3y equals to 6. When I sum them, so it'll be what? It'll be y's will be cancelled, and I'll have minus 11x equals to 11. X will be minus 1. I found a value for one of the variables. That means I have only one intersection with there's one intersection between these two lines. When I have to find y as well, so I will put x in here or here, doesn't matter. Which one looks easier? You just try it, and then you find x. Sorry, y. You have x, you will find y. And then when you put it, so it'll be 5 minus y is equals to 2. So in order to find y, I will place it here and place 2 here, so it'll be 5 minus 2 is equals to y, and y is equals to 3. So these two lines are intersecting in which point? In this point, which is negative 1 and 3. Okay. And B. What do we have in chat? Yeah. Yeah, when you find value of x as minus 1, because you don't have minus 1 here, minus 1 here, minus 1 here, you don't have it, just select B without finding B. You can do it. You can find multiple ways to solve this. You can find your own way, and when you solve enough questions, you will find a relation between mathematics and yourself. Okay, that way you can solve questions, you can understand other things, real life examples. Maybe you can understand the movements of planets. You can estimate, or you can maybe uh, uh, predict future prediction only with mathematics. Okay, so you can use mathematics to find relation between human and nature. So mathematics is really important. Actually, it is the universal language. Okay. So we will solve one more question, then we'll be done with system of equations. Okay. Question number 17 maybe. Yeah, simply genius. I know. Thank you. I'm genius. No, I'm not. I know that I'm not. I'm kidding. Okay. Question number 17. I have root of x. I don't have x. I don't have x to the power of 2. I have root of x. Doesn't matter. We can cancel it. I mean, we have to transform this into our original form, which was all x's and y's in one side, and other side we have only constants. Okay, so I will move it here, so it'll be y minus root of x is equals to 3. Oh, it's not working. Okay, so here I have 4 times x, right? I can take this out, or you can write a root of 4 times root of x. So this one, as you know, is 2 times root of x. So it will be 2 times root of x minus y is equals to 3. You can cancel the roots. It'll make your work really easy. Or you can cancel y's. When you sum them, you can directly cancel y's. So it'll be cancelled. You have minus root x and you have plus 2 root x. When you sum them, plus 2 minus 1 to be 1. So you will have 1 root x equals to 6. In order to cancel root, you will take power of 2 of both sides. So it will be x equals to 36, and x also equals to minus. Can it be minus 36? It cannot be minus 36 because you have x inside the root. But if you have something like this, for example, x to the power of 0, you can cancel this. X could be minus 36 and x could be 36. But here you have only x inside of the root. That is why you cannot have negative 36. Okay. I suggest you follow my lecture instead of chatting. It will be more beneficial for you. Okay, these are lines, we covered lines. And now we will talk about the movements of the graphs. How do we move them? If I have to move a graph 2 steps up or down or left, which methods I use? Or if I have to transform it completely, I mean, when you have something like this, for example, let's say, this is well known as y is equals to x, okay? So this line is y equals to x. When you have to take the absolute value of x, what that will be? When you take the absolute value of x, yeah, thank you. You cancel sorry. So you have normally you have something like this, right? You cancel the negative parts and you take it here, like a mirror. So this is a mirror, okay? You take this to other side, so that will be the graph of absolute value of x, okay, equals to. Normally you have what? This one, y is equals to x. When you take the absolute value, you erase the negative part. This is negative part, right? Because from here you go to negative part. You cancel it, and then you put it here. Let's say you have the graph of sine x, okay? You don't have to know this, no, you have to know this one, but you don't have to know the graph of sine x for SAT1, but it will be good for you if you know it. Then you'll be able to solve it, the questions really quick. For example, a question requires you to solve in a mathematical way, but you know it in simple way or Kachak way. We say Kachak way. You can find the answer really quick. Let's say this is the graph of sine x. Okay, sine x have a graph like this. The maximum value sine can get is what? Is 1. The minimum value sine can get is minus 1. So it's oscillating. Okay, so in order this is y is equal to sine x. When you have to find y is equal to absolute value of sine x, so you delete the negative part, which is these parts, and you move it up like this. You delete this and you move it up. Delete this and you move it up. So it'll be something like this. The graph of absolute value of sine x, something like this. So this is the way to take the absolute value of a graph. Okay, you delete the negative part and you move it to positive part. That's it. Okay. So let's clear all this. Let's talk about movement. I suggest you to follow the lecture, Alicina. What about sine absolute x? The sine absolute x is the same with sine. Is it the same? Absolute value x. Yeah, it should be the same because, for example, if you put it uh, minus 6, let me think about this. Minus 6 will be sine x6. Uh, hmm. You can find it using calculator, but it could be different. For example, in this interval, you have 0 and pi. There's no change here. There's no change here uh, until here. Yeah, you don't have any change here. But when you go here, this is negative pi over 2. Negative pi over 2 normally should be negative 1, but it will be positive. Yeah, it will be something like this. So this side of the graph will change, okay? So it's a complex form. You don't need to know this in SAT, but you need to know in SAT too. You can use graph, a calculator which has graph, okay? So let's talk about movement. Normally, or in general form, y is equals to x squared should be looking like this. Y is equals to x squared. And if I have to move it one step up or one value up, let's say this is 1, this is 2, this is 3, this is 4. If I have to move it up one step up, so sorry, something like this, it was in 0, right? Yeah, thank you. It was in 0. So when you move it up, so it'll be x squared plus 1. You add something outside the parameter of x, okay? Outside the parameter of x. And uh, if you have to move downward, one step down or two steps down, you subtract it, something like this. Uh, Here is negative 1. And if you have to move downward, you subtract 1 from outside the parameter of x, okay? So this is how we do it. Up plus, downward negative. But for right and left, it's completely different. We add a number or subtract a number inside the parameter of x. How? Let's say this is my original form of y is equals to x squared. When I have to move it right, one step right, let's say here, this is 1, okay? Originally, or before it was in 0, I step up to right, one step to right, so it will be x. Why it's not writing? Okay. Yeah. Who's writing, by the way? If you're writing, I cannot write it. Maybe you should write it. I'm waiting for you. I should wait for you to write. Yes, x minus 1 all squared. Am I right? No, all squared. Okay, we should continue. Yeah, that's enough. That's enough. The person with blue pen, that's enough. Yes. So we add no, we are subtracting 1 from parameter of x, inside parameter of x. So it'll be minus x minus. Why it's not writing? minus 1 all squared. Okay. Okay. When you have to move your graph one step to right, you subtract 1 from inside parameter of x, from the inside parameter of x, which is x minus 1 all squared. Normally you had x squared. Normally you had x squared. When you subtract 1 from x, from parameter of x, so you will have x minus 1 all squared. And when you have to move your graph one step to the left, you add something to the parameter of x. So let's say this is minus 1. I will have x plus 1 all squared. Okay, you add something to parameter of x in order to move your graph one step to the left. When you have to move your graph to downward, you subtract something outside the parameter of x, you add something outside the parameter of x in order to move your graph toward up, and then you do these operations to move your graph to left or to right. Okay, so this is some special graphs that, or movements of the graphs we use. Or I will give you one more example, and then we will end our lecture here. Or I will give a break, maybe. I will take a maybe. I will take your word and ask you if I'm going to continue with the class or not. So totally up to you. So we will solve one more example about this. Here, for example, in y is equals to x, if I have to add something plus 1, will it be upward? I mean, will I move my graph toward up or toward left? Sorry, toward left. Yeah, that will be left, because we don't have parameter of x here. We don't have x squared. When I had x squared, I will add x plus 1 in order to move it to left, right? But here I don't have parameter of x. I only have x, right? When I add something, I would have added to parameter of x and also outside the parameter of x. So it will be one step to up and one step to the left, because we added something to parameter of x and also outside the parameter of x. So it will be something like this: one step up and one step to the left. And when I subtract something from y is equals to x, so it will be something like this: minus 1 and 1. This is y is equals to x minus 1. Okay. When you subtract something from the graph, it will move your graph downward, right? And when you subtract something from parameter of x, it will move your graph toward right. But in here we don't have a parameter of x. We don't have x squared or x inside root, so that if I add something, so it'll be x plus 1 squared or root of x plus 1. We don't have such thing. That is why there's no parameter of x. When I add something or subtract something, it will affect the movement of the graph toward left or right, and also toward up and down. So if I subtract minus 1, normally it will move my graph to downward, so it will be minus 1, and also move my graph toward left, which is 1. Normally it was in 0, it went to 1. It was 0, it went to minus 1. So that's all about the special graphs and also the system of equations. That is all you have to know. There are lots of ways to explore and find your answers. You have to find it by yourself, okay?